redox half reactions that could either be oxidation half reactions and reduction half reactions. Okay, things like that. Okay, so I need to go to examples directly because we have already an idea how to predict and how to determine the oxidation numbers and the oxidation state and some of its basic rules with regards to their identification or detecting or seeing what will be their oxidation numbers. Okay, so again, redox, okay, is transfer of electrons. It's gonna be losing or gaining of electrons. Gaining of electrons. Just like saying losing electrons, we need to spend for food, okay, drinks, survive, or any basic commodities or necessities that we are trying to use for our survival. Okay, that's expenses. Gaining meaning there's something you added from your income. Could it be a passive income or should I say your active income? Because your active income, you will receive that later on and it will be added. For the moment, it will become your asset. Okay? It will become an asset momentarily if you will not spend. Because asset means anything that is added value to sales, money, or house, or car. Okay, once you will spend that, it could no longer be an asset. Okay? But if it will appreciate through the years, then it will become back your asset. For example, gold, jewelry, land, things like that. Okay, or business. You spend money for the business as your capital and later you can gain it back. So that is your asset. Okay, but the expenses will not be coming back. It's already an expenses. The point. Okay, so the same story with here. Gaining of electrons, usually non-metals and gases. Losing of electrons are elements. Okay, losing of electrons is the ability of an oxidation reaction. Then it's going to be like being oxidized. So meaning to say, losing of electrons is going to be following the pattern of being reducing agent. Okay, and then gaining of electrons follow the pattern of reduction, reduce, it's gonna be oxidizing agent. Okay, so it's gonna be, okay, it's gonna like saying that most of the metals are reducing agent and most of the non-metals are oxidizing agent. So the electronegative elements. Okay, don't be confused with the terminologies. Electronegative elements, meaning the charges are negative. Here, this is the electropositive elements. Okay. So now, from now on, change your mentality or change your perception that you will say that these elements or metals have no electrons. It has electrons because your idea of electrons is always negative. You get the point? It's not always negative. You get the point? Anak siya. Okay? Okay, mga palagingging. Okay. This is gonna be like that. Okay. Now, it depends also for the case in which you're trying to chemically react with another compounds. So, this will be not follow entirely with some few exemptions. That you can feel that somewhere when you have practice of your redox, okay, equations. Now, our topic is half redox reaction, like that. So, in half redox reaction, I will be able to introduce you basic steps. Okay, you already have this information, class? Not yet. I will erase now. Okay, I will erase. Okay. The first step is to balance the chemical reaction. Balance the chemical reaction. Okay. What do you mean by this? This is standard. The first step. Meaning you balance the number of atoms from the left and the right. Number two, balance the charges. So, your purpose of balancing the charges in order for you to get the number of electrons added or gained, or the number of electrons being reduced or loses, things like that, okay? You get the point. Now, here is a takeaway. Takeaway meaning important key point to remember. Okay, so oxidation, assuming that you are already done the balancing of charges. Okay, during your oxidation, you put the electrons in the product. You put the positive electrons on the product. You will put P. Okay, reduction. Because reduction is gaining of electrons from the terminology itself. Once you gain, you will be added directly. So you will put electrons from the reactant. So reactant plus electrons. Okay. Now, this is exclusive. It will never be interchanged. That's why these are the key points to remember. You get the point? Oxidation. Add the electrons in the product. Okay. Reduction. Add the electrons in the reactant. Then Sir Sotero, why there's no minus? You say oxidation is losses of electrons. Because in chemistry, you cannot put negative sign in your chemical reaction. Do you see negative sign in your chemical reaction so far? When you say HCl minus CO2 is equals, there's no such minus and positive. It's always plus. Your purpose only of the multiplication is to balance the charges, the atoms, but you can never do the multiplication also by reacting the reactant or the raw materials. You will never say HCl times 3 chlorine. Do you see this? Or you say CO2 divided by carbon dioxide or carbon monoxide. Do you see this also? Nothing. You can only see plus sign in all chemical reactions. If there is minus somewhere along the way, but you don't have to put the minus in the net equation. It's still positive after you subtract the two. For example, if your first half reaction is, let's say, 4 hydroxide, and your second half reaction will be 2 hydroxide. So you need to subtract. So 4 minus 2. Why you subtract? Because the other is from the reactant and the other one is from the product. You cannot subtract if both are in the reactant and in the products. According to the math rule, it's always the opposite direction that you need to add that one to give number. Okay? So basing also of the law of polarity, law of magnetism, and law of neutralization, is always the opposite will react. Okay? It's the same, polarity, or it has the same charge, and it will repel. That's also the reason why you cannot cancel in the same reactant and in the same inner product. Should always be the reverse, the reverse. The same also with the electrons. The reactant and the product you can cancel, but you can never cancel if the same. But what's good in electrons, you can add immediately. Okay, things like that. You will never subtract. You get the point? There's no subtract of electrons also. You get the point? And then multiply to something in order it will be cancelled. So we need to say the electrons there in adding here will be just temporary. Okay. See the adding of electrons in your net reduction equation. Always in the half reaction. Oxidation and reduction. Meaning at the end of the day, it will be vanished. Okay, the addition of electrons somewhere along the way. You get the point? Things like that. And our topic also for today is half reaction, oxidation, and reduction. Okay, things like that. So these are the technique, right? Okay, now we give you example. Okay, example number 1. Charot. Okay, zinc plus silver positive, okay, is equal to zinc positive 2 and then plus Ag. Okay, now is this a redox? Of course, normally, because there are elements. Again, if there's no elements declaration, that's not a redox. Always have elements and also a compound. But all are compounds, it's not a redox. Okay, meaning compounds in the product, compounds in the reactant. Okay, it's a mixture of elements and compound, redox. Okay, but all our compounds are not redox because that's the reason why neutralization reaction, acid and base reaction, it's not a redox. You get the point, things like that. Okay, now, so as I told you in a general rule, this is a zinc. This is electropositive zinc. So meaning to say free state, solo flight. So zinc is oxidation number is 0. Okay, and here it's positive 2. So meaning to say it loses electrons because it's smaller than positive 2. Then in a direct way, it increases the oxidation number. So we have to say, since it loses electrons and increases the oxidation number, so this is oxidation. Here, oxidation. Now make the half reaction oxidation immediately. Okay, half, okay, oxidation reaction, RXN, colon, okay, zinc. Now, when you do the half oxidation reaction, you need not to carry the 0. Okay? Our purpose only there is to determine the oxidation and reduction. That's why we need to put the 0. But during your half oxidation reaction declaration, you don't have to write it. Okay? It's very clear. Okay? Things like that. Now, what did I told you a while ago? If that is an oxidation, the adding of electrons will be on the right or in the product. So equal to, copy this zinc, so zinc 2 plus. So since there are 2 plus of charge, automatically you will add 2 electrons. Why? Because zinc loses 2 electrons. That's why we need to put the 2 electrons beside the zinc 2 positive. So that when you add the 2 electrons plus positive 2 is equal to 0, which is the oxidation state of zinc originally. So that's the answer of why. Again, I said, zinc is equal to zinc 2 positive 2 plus 2 electrons. So, Sir Lutero, why you add 2 electrons? Okay? Because I can also say, I will add directly 2 electrons because I see that 2 here, but that's only mechanics. You know, mechanics, only patterning. You pattern that of what is being done. So, science is not like that. It's not mathematics. Mathematics is more on sequencing, patterning, like that, okay? The gaps. But in science, there's a rule. So, you have to answer why. Okay. 2 electrons because it loses 2 electrons from 0 to 2. That's why I put 2 electrons here. That's the answer why I put 2. It's not the charge really, actually. Get the point? Things like that. Okay. Then we go to the half reduction reaction. So what did I told you a while ago? You need to add the electrons on the right. Right? Okay. Now, our reduction is obviously the Ag positive to A0. This is free state. So, see? That is positive and it's higher than 0. Meaning to say it gains electrons. The silver. Okay? See, positive is also zero. Meaning to say, when you say lose electrons and gaining of electrons, you have to compare the two electrons from the reactant and the product and base it on the reactant. If it is smaller, oh, it loses electrons. If it is increased, oh, it gains electrons, like that. Okay, but to avoid the confusion, just consider the oxidation state. So, okay, positive to 0, meaning 1 to 0, it decreases the oxidation number. So once it decreases, a synonym of decrease is reduction. That's why reduce, that's why reduction is the process. Okay, reduction here. Okay. Reduction, Ag, positive 1 plus, let's leave it that way, is equal to Ag 0. Now what electron you will add for this Ag? Remember I told you, it gains 1 electron from 0 to 1. So put 1 electron. Okay. Now, so why I go directly also, sorry to tell you, the first step is balancing the atoms because all are no having moles. That's why the atoms are all balanced. See? Zinc, zinc, Ag, Ag. In this case, it will be okay, but later on, if some mixtures of compounds, we will balance first. Okay? But in here, there's no issue. There's no atoms and moles. Okay? Things like that. Get the point mga palaging. Okay. Now, since electrons and 2 electrons, what did I told you a while ago? It should be lost during your net reactions. How can it be lost if the electrons are not equal? We cannot cancel. Right? So you need to multiply 1 with 2 so that it will become 2 electrons in the first in the oxidation. Okay. So this is multiplying the whole thing. 2 times Ag, 2 Ag positive. 1 electron times 2, 2 electrons. Ag, okay, times 2 is equal to 2 Ag. Okay, then add this from here. Zinc. Okay, zinc 2 plus 2 electron. Add the 2. So left and right, 2 electrons cancel. Okay, we have 2 Ag positive plus zinc is equals to, see, 2 Ag plus zinc 2 plus. Okay, now balance the totality na in your net reaction, both the atoms and the charges. Okay, let's check first the atoms. Silver 2, 2, perfect. Zinc 1, 1, perfect. Charges, okay. Silver 2 times 1 because positive means 1 automatically. So 2. Okay, sorry. Nakakaloka. 2 times 1 is 2. Then zinc, as I told you, free state 0. So that is 0. So 2. Here, 2 Ag, no charge to 0. 0 times 2, 0. Okay. Zinc 2 plus times 1, 2. So the charge is balanced. 2 in the left, 2 in the right, 2 in the reactant, 2 in the product. So perfect. Our charge has been balanced. Charge balanced. And also the atoms balanced. So this is our net redox equation. Now, if we have a perfect half oxidation reaction and perfect reduction reaction half, then it's expected that your net reaction will be perfect. How can we prove? By balanced number of atoms, by balanced the charge total. Okay, things like that. And that's it. Okay, for half reaction and reaction. Any questions so far? That would be all because, that's going to be the basic idea or the rules. Okay? Any questions so far, you can comment down below in the comment section. And you can also share this to your sons and daughters or to your friends or to your neighbors that are taking chemistry at this moment or at this particular situation or at present. And then you can comment down below also or drop off message in the chat in my messenger, FB messenger, so that we can discuss it professionally. And you can even also try to request, recommend some specific topics in which you like, and then I will be able to have a content on that, and I will discuss, and I will vlog it for you guys. Okay, thank you so much for watching. Bye-bye. God bless everybody. Now, half oxidation reaction and reaction class. And now we go to the net reaction discussion, net redox equation reduction. Partly like this, but there's a little bit of difference. In which I will be able to later. Bye bye. God bless everybody. See you later.